This is the fourth video in the STELLA 1.1 tutorial series. In this video, we're going to be going over the proto board and connecting the sensors and wires to it. So in this video, you're going to need all of the STELLA circuit components. So microcontroller, sensors. You're going to need the proto board, the wires, solder and a soldering iron, the 3D printed spacers for the microcontroller and the TIR sensor, and you're also going to need a pair of pliers, wire strippers and wire cutters, and a multimeter that can check continuity and voltage. It may also be useful to have a stand to hold your proto board and potentially a desoldering tool. You'll need to know how to effectively cut and strip wires, as well as soldering wires and components on the board properly. If you're not confident in your abilities, we recommend practicing these skills before attempting to put together the proto board, as this is a very long and tedious process. First, make sure to have the wiring instructions pulled up so that you know what pins the wires are going to. I recommend starting on the front of the board and focusing on the power and ground connections. Alright, so we're going to be connecting a power line. So this is going to be from A4, pin A4 to the power line down here. And first we can start by cutting a wire and stripping it. A little more there. Cool. Just bend the legs, the prongs of the wire down. It's going to go from here to there. Should look like that. Now we can flip it over and solder. Now, I recommend checking the continuity after every connection to make sure that there's no further issues down the line. If you wait until after placing the components to do your continuity test, there's a very high likelihood that you won't be able to access the connections and you won't be able to fix anything. So while it's generally not good practice to do all of the wiring beforehand, some wires are inaccessible once components are placed, meaning that they need to be done first. Okay, so what we can do is take our multimeter, set it to the continuity mode, just looks like that symbol. We can go power on the power line and just touch any pin in the row, and it should be continuous. Okay, now that you have all of your power and ground wires soldered in, your board should look like this. I like to do all of the wiring on the front before doing anything on the back. You might notice that there's these longer wires and these wires over here. So those are used for the GPS sensor. In our case, we are not using the GPS sensor. And if that's the case with yours as well, I would just go ahead and not solder these in. They're not necessary and they're going to serve no purpose. So just take those out. Alright, and this is what it should look like. Alright, now if we flip it over, these wires are necessary for the voltage divider. So this goes from B54 to B41, and this goes from D30 or D39 to D41. But what we can actually do is get rid of this shorter wire and just run a longer wire directly to D39. So this helps us eliminate one wire and another connection that can potentially go wrong.
The next step is adding the remaining electrical components such as resistors, capacitors, LEDs, and buttons. First, we are going to do the resistors that compose the voltage divider on the rear side here. These are 10 kilo ohm resistors and go from E39 to G39 and C39 to ground, and need to be attached before the buttons are placed on the other side. This is because once the buttons get placed down, some of the pins here will become inaccessible. Also, once these have been soldered in, you want to trim them to make sure they are as flush with the board as possible, because again, the buttons are going to need to be placed on top of them, and the flatter this connection, the flatter you'll be able to put the buttons on. Alright, so once the resistors are in and soldered and made flush, the next thing we recommend doing is going to be the LED and resistor. Going to be making something like this. We're going to want to bend the wires like this. How to do that is you take the positive leg of the LED, and that's going to be this long leg here. And then for this other leg, I recommend taking some wire. You can just take like a scrap of any of the wire you've made thus far, or you can make a new one if you'd like. And then take that loose rubber and wrap it around the LED like so, such that you can bend the negative leg like this. Why this is helpful is once you place the LED into pins B60 and B55, you're going to want the LED to be sticking out just slightly past the protoboard here, and this piece of rubber will cover up all the otherwise exposed leg to just make the device a little bit neater. Then the resistor is just going to plug into A60 to the positive leg and just go in like that. We recommend soldering this in now while the board and all its components are still relatively flat, but for now I'm going to show you how the buttons are going to get put on. So putting on the buttons, you're going to take the power button, that's going to go into A40 and the negative rail, and then just sit like that, trying to get it as flush with the board as you reasonably can. And then the push button is going to sit in between these other wires here. That's pins D36 and G36 you can connect this side to. You'll know that the buttons and wires and everything are put together correctly if one end of the button is connected to this blue wire here, and the other end is connected to this black wire that then leads to ground. Now we're going to put in the capacitors. If you are not using the GPS sensor like we aren't, you will be able to omit the 0.1 microfarad capacitor. If you are using the GPS sensor, the capacitor will look something like this. Note that it's a ceramic capacitor, meaning that it doesn't have polarity, so orientation of it doesn't matter. So you don't need to worry about that. But anyways, now we're going to show you the bypass capacitor. This is going to connect between the power and ground lines on the board. The instructions are going to tell you to put it in row 6. However, if you're using a taller capacitor like we are here, you're going to have a problem when you try to put on the case of the Stella. You'll find that it won't fit on. So to fix that, we're going to move the capacitor to row 16, and this will give us some space to be able to bend it down, give it a lower profile, and this will let the case fit on. The last capacitor to do is the one in parallel with the push button. So you're going to find pins J37 and 38, go on the back and slide those in, keeping note to have the negative leg closer to this side, closer to the black wire, pointing this way. But you may notice that right here, the negative leg and the ground wire aren't yet connected. So to fix that, we're just going to take a small piece of copper. This is actually the leg of the LED that we just cut off. I'm going to slide that in between H36 and 37, and then solder that down to make a connection. You should get it so you have ground wire into capacitor into blue wire in parallel with the push button.
Okay, after all of your electrical components are placed, the board is going to look like this. So we can go ahead and attach the microcontroller and data logger to the board. But before you do that, you're going to need to take your 3D printed spacer and attach that to the bottom of the microcontroller. Make sure the nubs on the spacer go into the holes on the microcontroller, and make sure there's as little of a gap as possible between that. Now what we're going to do is flip the proto board over and take our microcontroller and place it so that we have the legs going from pins C44 to C59 and pins I44 to I55. Now there should be a gap on the last row, and that's what it should look like. You can go ahead and solder this. Make sure that there's as little of a gap as possible between the proto board and the microcontroller. You can go ahead and solder the microcontroller onto the board and begin adding on components in the same manner as when you assemble the breadboard. So you can begin with the I2C sensors and soldering those on, and then finish with the UART sensor.
So here we have 3 of the sensors have been mounted and soldered already. Now we're going to show you how to do the last 2, the TIR and NIR sensors. For the TIR, you want to note the notch on the bottom here. This is going to be pointed towards the right on this video, or closer to the NIR. First you're going to take your spacer part and slide the legs through the spacer. You might need to pinch the legs a little bit to get it in. And then place the whole thing in between the VIS and BME sensors. Those are going to be on pins E2324 and F2324. You should notice that the legs on the backside will connect to power and ground on one end and clock and data on the other end. Also, because the legs have been pinched getting it in, there may be some springing force pushing the sensor away from the board, so it's probably a good idea to tape the sensor down before you begin soldering it. And for the NIR sensor, you're going to want to make sure you have the orientation correct. It's going to look like so. The row with labeled BLK and GRN should be pointing this way on the same side as the purple and yellow wires. And you're going to want to make sure that these line up with pins B2 through 7 on the other side. So once you have all of these sensors soldered on, you are effectively finished. Some things to note is that for the STELLA to be operational, you will need a coin battery installed here, and you'll need a micro SD card installed here if you want to be able to record any of your data. The last thing to put on is over here. We're going to mount the display board module that was made in the last video. So just line up the pins to the ports here and slide it on. If you're having difficulty with that, you may have some excess solder on the pins, or maybe some of the pins got bent accidentally while you were mounting it on. So just be careful everything lines up. It shouldn't take too much force to get that on. At this point, we're going to plug the device into the computer and turn it on. We should get a white screen on here. So we're going to go through and run all of the same test code you did for the breadboard process. The first test code I'm going to run is going to be the 2.8-inch display code, as you'll be able to see shortly. And then once I have this test code running, I'm going to run the bus scan next. And as you can see, if you run the display code first and then change it to another code, it will use the board as a serial monitor, and so you don't need the MU editor serial monitor to view. So from here, you're going to repeat pretty much all the steps we did in the breadboard process. You're going to go through all of the test code, all of the individual sensor code, make sure you get all of the addresses to show up, and repeat all those steps again. Once you have all of that working correctly, you will be able to upload the final code. So outside of the test codes folder, in the code and libraries folder, you'll be able to find the final code file. Then once you upload that, it'll look something like this. So if you're able to get to this screen, that means you're looking at an operational STELLA device. Now, in order to finish this up, I'm going to unplug it from the computer, grab your battery that gets plugged into the microprocessor on this side. And once that's done, you can grab your 3D printed lower housing and begin to slide the board in along the rails. This is going to be a pretty tight fit, so just be careful with it. Take your time. There's a slot for the battery to go in over here if you have the right type of battery. Want to make sure that the housing, none of the wires over here can get caught pretty easily. But otherwise, you can Great. Once you get all of that stuck together, you should be able to turn on the STELLA, give it a moment. And great.